Hello everyone and welcome to the last lecture of digital elevation models and applications. As we know that every good thing has to end. So this course is also at the last step or last discussion, and in this one we are going to discuss 2-3 things together in a quite a brief manner. One is the different DM sources from where we can get the different digital elevation models of different spatial resolutions. So I will be discussing one by one those known sources of digital elevation models, and also we will be discussing some limitations of digital elevation models. After all, nothing is universal, so everything has got the limitation. So digital elevation models, and especially the digital elevation models which are freely available at a global scale. So that we will be also discussing, and also we will throw some light about the future of digital elevation models, in which direction this development of digital elevation models and its derivative is going. So all these three things we are going to discuss briefly in this discussion. So let's start first with the spatial resolution, and then we will progress accordingly as per requirements. So as we know that nowadays for any analysis which involves the terrain, a digital elevation model has become virtually necessary or indispensable for such analysis, where topography is involved, terrain is involved. It may be topographic feature extraction, maybe slope aspect or drainage network derivations, maybe for runoff analysis, maybe for flood analysis, maybe for slope stability analysis, soil erosion analysis, even for siting of a tower or a building or a mobile tower, we need a digital elevation model. So these are indispensable nowadays, and same time lot of availability of digital elevation model is also there. So that is playing very important role. But at the same time we also always looking for accurate digital elevation model or representation, especially for the scientific research and sometimes for commercial or hazard related things. And military applications also sometimes looks for very accurate representation of a digital surface through a digital elevation model. So those requirements are also there. And DM, you know that accurately and to some extent replicate the landscape form and the processes which are critical to support modeling of environmental processes. So almost in various applications these DEMs are playing very important role. Now there can be always a discussion. At the end of this lecture we will have also little more discussion on what is basically the optimum resolution and optimum accuracy which is expected from a digital elevation model. As time is progressing, we are going towards better accuracy as well as improved or higher spatial resolution. So this higher or coarser spatial resolution is always a relative term. When we had 1 kilometer spatial resolution DM for entire globe, we developed we used such digital elevation models in various applications. Then came 90 meter, that became the higher spatial resolution. Then came 30 meter, so then that became the highest spatial resolution. Now people are talking about 50 centimeter spatial resolution DM or at global scale for entire globe. So that kind of discussion will go on, but basically we have to see what are our requirements for which kind of projects, which kind of applications or which kind of hazard I am going to use such a terrain information. So that is going to be more important than this. But as we know that for infrastructure, network planning, conducting a military intervention missions in unknown terrain or analyzing terrain features for oil and gas exploration, precise, reliable elevation data or especially digital elevation model can bring these analysis highly reliable. So everyone is definitely looking for accurate as well as high spatial resolution. Spatial accuracy also depends on spatial resolutions that we will discuss little later. Generally, many such applications analysis require a high accurate, a quality DEM, and accuracy of DEM is usually represented by spatial resolution or depending on spatial resolution and height accuracy. Because height accuracy has been an issue with the earlier digital elevation models, and if they are having a accuracy of 5 meter or 10 meter plus minus 10 meter, then at that time it was considered completely unreliable. But now accuracy has improved. This height or vertical accuracy is improving, coming within 1 meter in this global scale digital elevation model, and of course spatial resolution is also improving. So this accuracy part is definitely improving. Because the accuracy, if the input DEM is not accurate, then obviously the results are not also going to be highly reliable. So before we put a digital elevation model of a certain area for a very serious applications, maybe military or some hazard related thing or some commercial or scientific, it is always better to analyze the quality of a digital elevation model, and quality includes the accuracy part as well. This discussion we had earlier, that if we are having this height information from some other sources independent of digital elevation model, and then we can compare with that randomly distributed points of observations with the cells available in digital elevation model, then we can know or assess that how accurately a digital elevation model which I am going to use in that particular analysis. So this is always required for very serious applications, that one should first assess the quality of a digital elevation model, no matter from whatever the source it has come to for the analysis. This optimum accuracy of DEM for each analysis must be found. That can be determined based on what are our requirements. If if our project requires a very precise outputs, then we have to go for a highly accurate digital elevation model. If it is a small area, sometimes this can be also generated using field investigations first, and then digital elevation models generations, and then applications of that. Now these are the sources of very popular free digital elevation models available. I will go one by one through different characteristics of these digital elevation models, and like this is a SRTM DM, that is Shuttle Radar Topographic Mission Digital Elevation Model. Of course, it is global, about 85 or 90% of the globe has been covered, and the resolution earlier it was available for 30 meter, now it is also available. Earlier it was available for 90 meter, now it is available for 30 meter. The technique which was used to generate this SRTM DM was INSAR or SAR interferometry technique. Vertical height accuracy, as you can see, was relatively poor as compared to say Cartosat DM, which is giving 8 meter, or JAXA Global ALOS 3D Word DM, which is giving 5 meter. So compared to that, it is relatively poor, and these are the sites from where one can download these digital elevation models generated through this SRTM mission. Now these sites are have already processed the data, and they have removed the voids, which was a big problem, as also we have discussed during this course, the issues of voids in the INSAR data. So now the data which I am, or the sites which are shown here, most of these sites are providing data which is completely void free. If we go for ester GDM, which has been generated using a different technique instead of INSAR. This is based on stereoscopic pairs or stereo pairs data using optical data. It is also global and digital elevation model. This has been generated at 30-meter resolution. There is a little improvement in the vertical accuracy. Instead of 16-meter, now it is having 11-meter, and this can be downloaded from this Earth Explorer site of USGS. And then we are having this is not as that popular as SRTM or ester GDM, but it is now becoming popular because of this vertical accuracy part. This is also global. The JAXA, which is Japanese agency, space agency, ALOS, which they have used the ALOS 3D ALOS data generated using the stereoscopic pairs. The same technique has been used as in case of ester. Spatial resolution, that is 30-meter, but vertical resolution or height, this is 5-meter. Much improved accuracy is here, and therefore it is becoming very popular nowadays. It can be downloaded from this side. Then our own Indian digital elevation model, mainly available for India. Not all parts of India, but many parts of India, and in few years time, hopefully for entire India, this would be available. The best part here with the Cartosat, that it provides the spatial resolution at 10-meter. Vertical accuracy is also quite good, around 8-meter, and this is a little different stereo pair techniques have been used. This is along track stereo images, which is a new invention was done when this Cartosat was designed. Instead of side looking, it is along track. So two cameras, one was looking forward, one was looking downward or backward, and likewise stereo images were generated, and then these have been processed to generate digital elevation model at 10-meter spatial resolution with 8-meter accuracy. This can be downloaded through Bhuvan, which is a sort of equivalent of Google Earth. So 4 types of digital elevation models are available for India, 3 for global, and 1 only for India. One by one I will take these sites also, which I have just mentioned in the previous table. This is the Earth Explorer site, so one can choose. This is completely interactive, and one can choose the type of data which one would like to download, search the area of interest, and then you get the links and which you can later on download. So this is Earth Explorer interface for SRTM DM and ester 3D World, which is ALOS, which is also can be downloaded. Now this is especially SRTM tile graver. So large tiles of SRTM 30-meter resolution can be downloaded from this site, which is SRTM tile graver, and this is well processed data. All voids have been removed, large tiles are available. So this makes things little simpler compared to the other sites. And this can be accessed from there. Then we are having another site of the JAXA, that is Japanese agencies of ALOS DM, and that can be again large tiles are available. So those tiles can be downloaded for any part of the globe, because this is a global. So this is JAXA Earth Observation Research Center URC interface for ALOS DM. This is the Bhuvan interface, and here also the grid will be there as in other sites, and you select the grid and then link is available. You download the DM of Cartosat. So a high resolution digital elevation model for almost a large part of India are available for downloading, and because of it provides a better spatial resolution, relatively better spatial resolution, and also higher vertical accuracy. Therefore, for Indian studies of Indian areas, this is can be used extensively. Now other sources, there are some other sources of digital elevation models also exist, like ESDI is a, maybe the data is same, but the sites are different, so their interfaces are different. The way they allow you to download is also different. Some may like this way, this ESDI. I like personally I like this site because the interface is quite good and very interactive, and as per my requirements it can give immediately the number of tiles, which tiles I have to download. So that is available. There is another digital elevation data, CGIAR CSI Geoportal, which also provides the global data, and this is wide field SRTM data is available for entire globe. Then at 90 meter at 5 degree by 5 degree tile, then also 30 meter by 1 degree by 1 degree tiles. There are some other sources like this National Geophysical Data Center NGDC of US, which is again digital elevation models of multiple resolutions can be downloaded. And of course the earlier the TopoSeed based the eTopo2 database is also available for downloading. 30 arc second 30 seconds gridded land topography data is also available, that is 1 kilometer. Then you are having 1 arc second, that is 30 meter is also available SRTM. So many sites are now becoming sort of depositories of digital elevation models of different organizations which have been generated using different techniques. So that is one of the advantages, that you just if you forget about these sites, the best way is to just type in say in Google that digital elevation model free download, and you will get almost all these links one after another. So whichever the interface you like, whatever the requirement of your work and the spatial resolution, other things, you can just go learn little bit about that interface. Maybe sometimes you have to create a login, username, ID and password, and then after that you are allowed to download this. So all free, all resolutions whichever I have discussed, all are freely downloadable digital elevation models of almost all part of the world except for Cartosat, which is available for India only. Now we will discuss little bit about limitations of digital elevation models. As mentioned earlier in the beginning of this discussion, that no tool or no technique is universal or perfect. Everything has got the limitation. So our digital elevation models, and the biggest limitations or discussion point always has been with digital elevation models is spatial resolution. As also indicated that when we had 1 kilometer spatial resolution, still that was useful. Some people, when they are working at global scale for climate change and other things, they may not like to have a 30 meter or 10 meter spatial resolution digital elevation model because of huge handling of extensive handling of digital elevation model. So they might prefer even 1 kilometer digital elevation model initially, and later on for very small or regional studies one may go for higher spatial resolution. So spatial resolution basically it is always thought in relative terms, and I always consider as per requirements. If I am going to cover entire area, then 10 meter spatial resolution may not be advisable depending on again the application. If I am working for a flood related studies, then I might require a high spatial resolution. But if I am working for some vegetation related thing or some other phenomena like drought and other things, I may not require that kind of spatial resolution. So spatial resolution is always considered in relative terms as well as per requirements. Vertical resolution, as you know, that this is basically the least count you can say, whether the values are varying in terms of meters or in centimeters. Generally the values of cell of each digital elevation models are given in real numbers. So the values are even available at centimeter level. So that vertical resolution is good. The vertical resolution and vertical accuracy are two different things. Vertical accuracy can only be assessed once we are having some standard data or data height data available from some other sources. But vertical resolution is at what is the the resolution or the precision of the data in terms of height. So that vertical resolution is different here. And then coverage. If I am going to work on a very small area, I don't bother about whether globally the same digital elevation model is available or not. So if I am working in a part of say Uttarakhand or central India, I would be and my area of research is quite small or area of interest is small, I would like to use the Cartoset because it will provide high spatial and vertical resolution, and accuracy wise is also quite good. So vertical accuracy we have already discussed, and that plays very important role. So these while considering a digital elevation model for any study, one should assess the availability of digital elevation model on these criteria which I have just discussed, that spatial resolution, vertical resolution, the coverage and vertical accuracy. Now further on these limitations, that areas related to DM uncertainty that affect the use of DMs, the DM error. If while if interpolation techniques have been used to generate digital elevation models, what errors have come through while interpolation was done, that one should know. So errors may be the technique in SAR interferometry which has been employed. There will be some introduction of errors. So one should at least aware about the errors, because as you know that in processing of a digital elevation model on a GIS platform, error propagates. So if we know the error, then accordingly the care can be taken so that error doesn't propagate, or if it at all, then we should know the reliability or the confidence in our results. So if we are having highly accurate DM, we know how we can have a high level of confidence. But if we know very well that our DMs which I am going to use in a certain analysis are having errors, then my level of confidence is going to be quite low. And the other thing which is also related with this, the topographic parameters which we derive from digital elevation model, and the algorithms which we use to drive these parameters. While discussing like slope map, aspect map, I have discussed the jet factor. So these are the, though they looks very small, but if jet factor has not taken care, the entire output becomes unreliable. That means entire slope map, aspect map, or any other output which involves the jet factor becomes unreliable. So while driving such parameters, all options even in a software has to be first understood, then only we should proceed for processing. And the influence of DM scale is imposed by the grid cell resolution. So scale will come as mentioned also during the discussion in this course, that scale is frozen once we either print or project a digital elevation model. So if I am having a medium resolution digital elevation model, and then on a small printout, then there accordingly it will fit in that scale. So generally high resolution digital elevation model, when I print or project, I may get a very sharp picture. But scale is a little different. It is only fixed once things are printed. As long as digital elevation model is in digital form, that is inside the computer or in a computer memory or a disk or other things, then scale is not there. So it doesn't have the scale, only it is having the spatial resolution. DM interpolations, I have already discussed that if I am generating digital elevation model using point data, then different interpolation techniques, as we have discussed in this course, might bring some errors. So it is better always to check at that time which is the best suitable technique for my data set, number one, and how much error it might be carrying. So that assessment has to be there. Now these modifications about the terrain surface which are required while doing this hydrologic modeling, surface hydrologic modeling. So that is also very much has to kept in mind, because we fill the sinks, and because we are going to use that digital elevation model for surface hydrologic modeling. Now probably the same digital elevation model should not be used for other purposes. So the terrain surface modifications, which we are doing the modifications to our existing digital elevation models, generally we go for in hydrological modelings, but may not be required in other one. So that may become error for other product, but it is a error which has to be removed for surface hydrologic modeling. Errors in digital elevation models and the propagation, this part I have already discussed, that error propagates when we drive certain products or certain derivatives outputs from a digital elevation model. So if I know that how much error is there, accordingly I can assess the errors in my output as well. Now different applications may require different spatial resolution DMs, because all applications do not require, for example, very high spatial resolution digital elevation models. As given the example that if I am working on a global scale, then a relatively coarser resolution digital elevation model may be more than sufficient. But if I am working in a small area at a very large scale, then I would definitely prefer a very high spatial resolution digital elevation model. So I am giving you some examples, though it is not perfect, but based on certain experiences of different people. Like Sharma et al. In 2012 has assessed that for hydrological applications, 90 meter, that is most popular one is SRTM DM, which we had earlier launched. Void free DMs may be very sufficient for sufficient spatial resolution for such hydrologic applications. And another example for landform classification is topographic positioning index, which we have discussed. And there if a 50 meter or 30 meter digital elevation model can be employed for that purposes. And this of course when we will use a relatively coarser resolution digital elevation model, the number of categories of landforms should not be large. We can restrict ourselves to 6 to 8. So if in a terrain landform categories are not varying, they are just 6 to 8 in range, a rough estimation, then a relatively medium range spatial resolution and DMs may be suitable. This was assessed by Takagi et al. In 2002. And for other terrain parameters like slope, aspect and other things, and maybe for a small area, then optimum grid cell size or the spatial resolution may be of range of 5 to 20 meter. Again, these will depend on terrain complexity and terrain derivatives. The terrain complexity means whether terrain is highly rugged or smooth or a plain area. So if I am working in a plain area, I would like to have a more vertically accurate digital elevation model, may not be very high spatial resolution digital elevation model. But if I am working in a hilly terrain, then I would prefer that I should have a relatively higher spatial resolution digital elevation model, and of course as better the vertical accuracy is. So depending on our applications, we may choose different digital elevation models. The best part is that nowadays all kinds of options about the spatial resolutions of global digital elevation models are available for our choice. Another thing is highly accurate DMs are required for floodplain modeling, because this is where every inch of water or every centimeter of water will inundate more area, and accordingly therefore we always look for high spatial resolution and especially high accurate. That means vertical accuracy has to be very good if I am going to use a digital elevation model with the flood related studies and modeling. And the other conventional digital elevation models which are maybe available of a 10-meter spatial resolution, maybe from a spot and others, but for a small area these are not available for global scale. This is a diagram from, or this figure is from a word of remote sensing, but it is still applicable. That probably what is desirable when we would say that now we have got sufficient spatial resolution digital elevation model. Though this diagram is little older, but it brings the same thought as I wanted to discuss here, that this circular area, these values are changing. So instead of 100 meter we may talk now 10 meter here, that is the desirable spatial resolution. As things are improving, we are moving towards more lower or higher and higher spatial resolution, that means lower values, and towards the origin of this XY plot. So this is the desirable area, but this desirable area has shifted now to about 10 meter, where people are finding very useful for areas or for studies which involves a local area. So this is if you see that because lot of digital elevation models are coming based on different satellites and different techniques, and all are indicating towards that. Though as I have been saying that this has to be shifted now little bit around this 10 meter instead of 100 meter, because this is a old figure. It was true in case of remote sensing data a few years back, but now things are changing, improving if we was to call, then it is keep shifting to that extent. So the desirability is always for higher spatial resolution in most of the cases, but I would definitely suggest that if I am working for a large area and going to cover at continental scale or global scale, then moderate resolution or coarser resolution digital elevation model would be more suitable, because the handling data processing requirements. If I go for very high resolution digital elevation model, then the processing requirement would be huge. I may not be wanting results at that resolution. So requirement based utilization of different elevation models should be there. Availability, what is the availability of a digital elevation model for that area, like Cartosat is not available at global level. So if we are working for India it is fine, but if we want to work on some other areas, then we have to look the availability, the processing capabilities, because higher spatial resolution means more processing and so on. And this we have to understand about the local to global, and whether that analysis has to be done at global scale or local scale. Accordingly the spatial resolution should be decided. Now the last topic here is the future of digital elevation models, in which direction we are going. So we have moved from 1 kilometer to 90 meter to 30 meter, now we are talking about 10 meter, and do we have something higher available or thinking, or some development is taking place. So it is the best time in this course to discuss at the end what is the future of digital elevation models. So NASA is going to create a NASA DEM which would be more accurate than other DEMs, and they have planned in a big way, and this will be again a global DM. Of course, they will be utilizing all SRTM data and other data sets, including ASTER and other data sets, and then will bring a digital elevation model at global scale. That would be probably called NASA DEM. Now, this is NASA has proposed a significant modernization of publicly and freely available DEMs, and the current DEMs, SRTM 90 meter, 30 meter, these are most intensively downloaded data sets in the history of NASA. And however, due to number of restrictions and limitations, the original full resolution DM and the error backscattered coherent layers were not released to the public. Because initially only 90 meter resolution digital elevation model of SRTM was released, later on 30 meter. Now these more processing will improve, better processing probably will improve the resolution, and we may get in future maybe SRTM 10 meter resolution. So that is probably also the one of the targets of NASA DEM. And NASA also proposes to reprocess the original SRTM raw data involving improved algorithms and incorporating other data sets which might be available from other sources to improve the existing SRTM DM. So that NASA DEM hopefully would have much more better, accurate, maybe higher spatial resolution DMs. Now if we look little bit about the global digital elevation model market, the first thing we can say, it is highly dynamic. Things are changing at a very rapid rate. Only few years back, the highest spatial resolution digital elevation model at globe was available in 90 meter. Now for India, we have started talking about 10 meter. But maybe even 0.5 meter, which I am just going to discuss in few second time. As we know that DEMs are used for different purposes, so there is a upsurge in the use of digital elevation models, and therefore lot of demand and lot of supplies of digital elevation models accurate at different resolutions is also going to grow from global to local market. If we go for higher spatial resolution digital elevation model, maybe for 1.1 meter to 5 meter, still it is very high, because these are not available freely, and neither they are available at global scale, only for a local scale. So you have to order, then processing will be done, implying higher spatial resolution either in SAR data or your optical data. Now the always end users may be looking for higher spatial resolution and data, whether that demand can be fulfilled by the industry or the developers, that will be seen in future. And as I have said, that the market is very dynamic. Today whatever we say is high spatial resolution, tomorrow that becomes the coarser resolution or medium resolution. But there is another focus on the accuracy, not only the resolution, but accuracy of digital elevation models. So that is also improving day by day. And the quality and availability of remote sensing data is improving the digital elevation models, and this is the accuracy and spatial resolution is increasing, and therefore also there is a intense increase in the utilization or applications of digital elevation models. Few applications, few products we have discussed, but as I have been mentioning in this course, the digital elevation model is a storehouse of information. Some of the information we know how to extract, but still there might be some information we may not be knowing about that. And the digital elevation global market is always looking for high resolution. There are different techniques, but for very small area, these high spatial resolution, high accurate, vertically accurate digital elevation models are available. Of course, as per demand, based on a customer, such high resolution digital elevation models or digital surveys models are generated, maybe for some airport, maybe for some construction site and some other thing. And now the future is, one more thing is coming from this satellite, which is PLI-DES, which is going to offer a 0.5 meter spatial resolution DM through the probably the same with the stereo data. And this is one example of that, of Melbourne city, Australia, which has been created this digital surface model here with the spot 6 and may at 0.5 meter, that is 50 centimeter spatial resolution. So now we are going sub-meter spatial resolution. So this is going to use the stereo data and can generate, but this is not yet in market. It will be coming very soon. So this brings to the end of this lecture and also end of this course. We have discussed from beginning to end what is different types of digital elevation models, what are the accuracies, spatial resolutions. We have also discussed various types of derivatives, and also in between we have discussed where digital elevation can be applied, can be used, and where these are being applied through some examples as well. And also we have looked the limitations of digital elevation model and future of digital elevation model. So basically this brings to the end of this lecture and this course. I am sure you must have enjoyed it. Thank you very much. All the best.